Welcome back to Exploring the Wonders of Quantum Mechanics. In today's in-depth episode, we're diving into the mind-bending world of quantum teleportation. We'll explore how this phenomenon, once confined to the realm of science fiction, has become a reality in the realm of quantum physics. Let's embark on this journey. Quantum teleportation is a fascinating phenomenon that allows the transfer of quantum information from one location to another, seemingly instantaneously. But what exactly does it entail? At its core, quantum teleportation is about transferring the quantum state of one particle, usually an electron or photon, to another distant particle while destroying the original state, meaning it is a non-destructive process. This transfer happens through a process of entanglement and measurement, which we covered in prior episodes. To understand quantum teleportation, we need to break down the intricate steps involved in this process. Step 1. Entanglement. Two particles become entangled, meaning their quantum states are intrinsically connected. Changing the state of one particle immediately affects the other, regardless of the distance between them. Step 2. Measurement. The sender, often referred to as Alice, performs a special type of measurement on the particle she wants to teleport, also known as the quantum state particle. Step 3. Transmission. Alice communicates the measurement results to the receiver, often referred to as Bob, through classical communication channels. This means that quantum teleportation does not violate the principles of relativity by transmitting information faster than the speed of light. Step 4. Quantum state reconstruction. Armed with the measurement results from Alice, Bob performs operations on his entangled particle to recreate the exact quantum state of the teleported particle. Quantum teleportation is more than just a fascinating phenomenon. It has profound implications for the world of quantum computing, communication, and cryptography. Quantum teleportation is crucial in quantum computing because it allows for error correction and the transfer of quantum bits, qubits, between quantum processors, potentially enabling powerful quantum computations. In the realm of quantum communication, teleportation offers secure transmission of quantum information using entangled particles, making it a cornerstone of quantum cryptography, particularly in quantum key distribution, QKD. Quantum teleportation continues to be a hotbed of research and innovation. Scientists are exploring its potential applications, including quantum networks and even quantum teleportation between different types of particles. The development of practical quantum teleportation systems faces challenges related to the preservation of quantum entanglement and the efficient transmission of quantum information over long distances. As we conclude this in-depth exploration of quantum teleportation, it's clear that this phenomenon transcends science fiction and holds remarkable promise for the future of quantum technologies. We hope you enjoyed exploring the mind-bending concept of quantum teleportation. Quantum physics continues to push the boundaries of our understanding, and we'll be here to unravel its mysteries. Until next time.